Well, thank you very much, Sarah, and thank you to Cencos and Proactive for inviting me and CAP-XX to present today. Let me just skip through the disclaimer here and tell you a little bit about CAP-XX. Well, we are a global leader in the development, manufacture and sales of supercapacitors. To date, we have sold over 40 million cells. We're based in Australia, headquarters, and our 4 newest production lines are all in Sydney. And we have 2 other manufacturing sites in Asia. They're complemented by 3 sales offices, 1 in the US, 1 in Germany, and 1 in Australia, and supported then by a global network of distributor and sales agents. We have only 33 full-time employees, most of which have some form of postgraduate qualification and would fit comfortably under the title of scientists and engineers working on R&D and product development. Of course, that number excludes the production staff that are operating offshore. And that heavy emphasis on R&D and engineering staff, not surprisingly, is directed at developing intellectual property of value to CAP-XX. And we have 11 active patent families with more to come. And we have successfully licensed a number of, we've sold licensees to our intellectual property to 5 multinationals. Some of those names, the people on the call here will recognize, I'm sure, such as Panasonic, TDK, AVX, Murata. So moving on then. Now, for those of you who are new to the CAP-XX story or may not have heard about us before, let me tell you that we have had an extremely busy and rewarding last 2 years during COVID. We have constructed a new production facility in Sydney, along with a headquarters there. And that has been made necessary because we needed somewhere to house 4 new production lines that we relocated from Japan, where they were being operated and built by Murata, to Sydney, Australia. And we did all that during COVID, and we were able to do all of that and bring it and set it up and get it running on time and on budget, to which I'm quite in awe of our team of how they were able to manage that. So well done to them. Now, as I said earlier, CAP-XX develops, manufactures and sells supercapacitors, and we're probably best known for our ultra-thin prismatic range. It'd be fair to say that globally, there is no other company in the world that has our capability to make high-power supercapacitors in a very small, thin form factor like we do. And that gives us undoubtedly an edge, and that is being complemented by these new production lines we have, and you'll hear more about that shortly. We also sell small cylindrical supercapacitors. We sell large cylindrical supercapacitor cells and also large modules, and this will be a growing part of our business as well going forward. So a supercapacitor on one level is not dissimilar to a battery. They both store electrical energy and they both deliver electrical power. However, if you dig a little deeper, there's a very great difference between batteries and supercapacitors. Batteries rely on chemical reactions to both charge and discharge, or to store energy and then discharge energy. And those chemical reactions are slower than physics, and they also inevitably have unwanted byproducts that degrades the battery and over time limits the life of the battery device. Supercapacitors, on the other hand, rely on what is known as the electric double layer effect. So essentially we're charging or storing the energy using what is known as charge separation, a bit like static electricity. Ideally, there's no chemistry involved. And so there are no chemical byproducts, no chemical side reactions that lead to a reduction in life. And because it's physics, not chemistry, they operate so much quicker. And these develop some of the great differences between supercapacitors and batteries around just how much longer a supercapacitor will last, how many millions of cycles it can charge and discharge for compared to a battery, and just how quickly they can operate to charge and discharge. Similarly, traditional capacitors do not store anywhere near the same amount of energy as supercapacitors, and as illustrated by this slide here. The top half of the slide shows that one of our small supercapacitors will deliver more power than over 2,000 lithium-ion coin cell batteries, quite a significant amount. So this, not surprisingly, has led to a growth in the supercapacitor market. It's been growing strongly, also evidenced by our own sales. During COVID last year, our own sales increased by over 30%. But the overall growth in the supercapacitor market is recognition of the limitations of batteries, both from an electrical point of view and also an environmental point of view in terms of limited recycling of batteries, limited life of batteries, and how to dispose of them. And this is driving a lot of our customers to redesign their applications to include a supercapacitor in there. Let me give you two examples of why customers, of the sorts of problems that customers have where we can solve that problem for them. The first case is where they may have an application that requires more electrical power than what the battery they have can deliver. And maybe they don't have an option of using a bigger battery. Maybe it's too expensive to increase the battery. And they're limited by the battery. And by using a supercapacitor, a small supercapacitor typically, now they can get far more power because the battery can slowly charge the supercapacitor, and the supercapacitor can provide all the power needed for the application. Whether that happens to be some sort of heavy machine lifting like a crane, or whether it's driving a mobile phone radio or IoT radio or LoRa network or a little pump, whatever, the same principles apply. And the other application or problem that we're seeing more and more of is the desire to use energy harvesting. So rather than relying on primary or secondary batteries, using the energy that's abundant around us, such as light energy, so using a photovoltaic cell to capture energy, transfer that to the supercapacitor, which then becomes a self-sufficient, self-powered device that can do everything from opening door locks to powering radios or transmitting vibration data in a predictive maintenance area. So this growth in supercapacitors is happening across many different markets that you can see here, from small electronic markets like IoT right across to large buses, trucks, trams, etc. CAP-XX is seeing especially strong growth coming out of the IoT markets. And this also known as the Internet of Things markets. And we expect, and as do the market analysts, that this demand or growth in the IoT space will continue for many years to come, because there are so many systems and products that are currently on legacy 2G, 3G, 4G cellular networks that are being closed down, and it will need over time to migrate to LoRa or narrowband IoT or 5G and in the future even 6G. So we see a very strong growth and demand for supercapacitors from this demand pool coming out of the IoT sector here. And not surprisingly, that has led to a very strong pipeline for CAP-XX. And that's also evidenced by the recent customer wins we've had, which include some of the examples on this slide. We have dash cams for trucks, buses, private automobiles. We've got smart e-bikes, controlling the e-bike, locking the e-bike. We've got sensors built into the roads for traffic flow and sensing traffic loads over a piece of roadway. We have energy harvesting modules to replace batteries for self-contained IoT sensors, typically used in smart building controls, for example. We have electronic locks, so the supercapacitor being used here to open and close the lock. We've got the announcement that came out today from FCCI which is using supercapacitors to power LoRa sensor networks. Portal Instruments with their needleless injector. So here they're using 8 of our supercapacitors to provide the electrical power needed to inject medicine at a very high pressure, but without using a needle at all. Predictive maintenance systems from Everactive, which are using CAP-XX supercapacitors and no batteries to monitor rotating machines and transmit that data back to some sort of central maintenance depot. Wearable health tags, Quectel, which is wanting to use very long life lithium thionyl chloride batteries, but which these batteries have very low power. So again, they're using the CAP-XX supercapacitor to augment these batteries. Smart meters, car key fobs, car sensors, renewable energy storage on a large scale, and consumer products like this 5-phone music player. So quite a lot of using of new design wins across a wide variety of markets in the IoT space.
You're just overrunning. You've got about 60 seconds.
Okay, I'll be very quick there, Sarah. So going forward, we're very much focused on our 5-point growth plan. The first one is to get the absolute best out of the new production lines in Sydney, using and delivering on our DMF, DMT products to get the right output and production metrics. 2 is to introduce new products into the IoT space. 3 is to add new products, especially our DMH and other new products which are in our pipeline. The DMH product, by the way, is only 0.4 of a millimeter thick, so it's like a couple of human hairs. 4, enter transportation and renewable markets with large cells and modules, and to enhance all of 1 through 4 with organic growth through targeted partnerships and licensing. So in summary, Sarah, fast-growing business. We've got strong organic sales, high gross margin, strong brand recognition, focused on some really exciting markets, and we're driven by a strong ethos of product innovation, great R&D and engineering team, lots of patent families, more ones being filed, lots of engagement with universities and development partners, and look out for new products coming down the pipeline. Thank you very much.
Thank you indeed. We have time for one question. So you talk about the fast growing business, there's new production lines in Sydney, and Steve Barnes asks, do you envisage needing more manufacturing capacity due to increasing demand?
Great question, and the answer is not at the moment. So the lines that we brought from Japan have a lot of excess capacity, and that will certainly, even with really robust growth, that'll keep us, give us enough capacity for the next couple of years. So I think we're right for now. Thank you.
And you got a very beautiful tax rebate. Those are always beautiful surprises, though I'm sure it wasn't a surprise. So you've got this tax rebate. Do you have plenty of cash?
We do. So that's a great point you brought up, Sarah. The Australian government effectively gives us 43 cents in the dollar back for every R&D and engineering dollar spent, which is one of the reasons why we can afford to have a relatively large R&D and R&D engineering product development team for such a small company. So that's very useful, and we put it to good work. We get great leverage out of that in building up that IP pipeline.
Thank you very much. Anthony Congat's Chief Executive of CAP-XX. It's been a pleasure. Thank you very much indeed.
Thank you, Sarah. Bye.